Right. Inequalities. First of all, a reminder about interval notation. We're going to write answers in three different ways. Using interval notation, a number line, and compound inequalities. And we'll talk about all three of them as we go through this process. Now, just a reminder on interval notation, which was something that you learned in the first lesson in the Algebra 2 book. Talked about interval notation. And that means, so here in this tan box here, all right, it talks about compound inequalities and interval notation. So here's the thing, all right? You recognize things like what's here, that x is greater than or equal to c, less than or equal to d, right? That's a compound inequality. That means if I graphed it on a number line, I would start at c with a solid dot, go to d with a solid dot, and I would fill in the line, right? Make it a bold, solid line between them, okay? If I'm using interval notation for them, I use brackets, okay? So this means I start at C, go to D, close dots, okay? If it's a less than sign, okay, without the equals, we know on the two ends they are going to be open dots, okay? Fill in the line between them. In interval notation, we use parentheses to represent when it does not include the point. Okay? So brackets when it includes the point, parentheses when it doesn't. All right? Interval notation. So we have here in these four situations interval notation and compound inequalities. Right? Now those compound inequalities are always when they come together. Okay, so that is when we use the word and. Okay, so I would say that x is greater than or equal to c and x is less than or equal to d. Okay, comes together. If they go away from each other, then it's an or situation because I would have to have this or that. It's an and situation here because it has to meet both criterias. It will be an or situation if they go away and it can only be one. You can't meet both. And if we have a situation like x is less than 5, and when I write interval notation or compound inequalities, you always go from smallest to largest. Okay? So if I say x is less than 5, well, what's the smallest number less than 5? Negative infinity. Oops, I just put infinity there. It should be negative infinity to 5. So I would have parentheses because is negative infinity an exact value? No, so I would use parentheses then. Okay? If I had x is greater than or equal to 5, right, so there should be a negative sign there, then I would say my smallest number is 5, and the biggest number then would be, smallest number is 5, but it includes it, so I use a bracket. The largest number is positive infinity, which is not an exact value, so I use a parenthesis. Okay? All right, interval notation.
That's like a 3D potato chip.
Oh my gosh, it does. It looks like a Pringle.
Nice. All right. Basic principles for solving inequalities. All right. Add or subtract the same quantity on both sides of the inequality. Multiply or divide both sides of an inequality by the same positive quantity. What happens if you multiply or divide by negative?
Switches.
Okay, we change the direction of the inequality sign then. Okay? All right, here we go. So it says, when solving inequalities, show your solution in 3 ways. Graphing on a number line, interval notation, and compound inequality. All right, number 1, you have this one, right? Okay, what's the problem with this? For you, not for me, for you.
We have to do 2 of them.
Right, you have to do 2 of them. It's written in the middle, so I have to pull it apart and do two separate inequalities. So we're going to do negative 5 is less than or equal to 2x minus 1. And we're going to do 2x minus 1 is less than or equal to x plus 7. So it's just the 2x minus 1 goes with both parts. You solve the inequalities. All right? So this is just like solving linear equations with an equal sign, except if you divide or multiply by a negative, you have to change the direction. Okay? So go ahead and solve both of them then.
Only if it's a negative, you have to use it.
If you're dividing by a negative, yep.
Divide or multiply.
Either one. Okay, so first, my suggestion to you in your doing your three different answers is first use the number line, okay? Because then the number line should make it clear what happens. Right? So when you do your number line, here's my requirements for you on that, okay? Is you just need to show me one number less than on each side of the two numbers, okay? So my smallest number here is what? Negative 2, the largest number is 8. So you have to go from negative 3 to 9. All right? Make sure all of your intervals are all the same, okay? But go from negative 3 to 9. So if you want to go by 2s or 3s to get there, I don't care. But the minimum, the most you must show me is at least negative 3 to 9. So maybe I'm going to go by, I'm going to go by 3s. No, I can't go by 3s, sorry. I can, but... There we go. All right, so I decided to go by 3s, but I got to put the ones between there because I need to see negative 2 and 8. All right. So what kind of dots are going on negative 2 and 8? Closed dots, okay? So negative 2, closed dot, positive 8, closed dot, if there was no equal sign underneath the...
So just less than.
Yes. Yep. And then we bold in this line connecting them. Okay. So then that means that x is greater than or equal to negative 2 and less than or equal to 8. There's my compound inequality. And then do I use brackets or parentheses? Brackets. So bracket, negative 2, comma, 8, bracket. And there's the three different answers. All right. Number line, compound inequality, and interval notation. All right. So you do number 2. So open it negative 2/3, open it 2. So we're going to do parenthesis. Let's do the compound inequality first. Compound inequality, so x is greater than negative 2/3 and less than 2. And so parenthesis, negative 2/3, comma, 2. So just always remember, and this is where I find mistakes, is people will not write these in the correct order. Because when you solve them, the smallest one isn't necessarily going to be on the left side of your work. It might be over here on the right side of your work, but you need to make sure that you do smallest to largest when you write them. Okay, all right, awesome. Okay, solving other inequalities. Hey, look at what we see here. What do we see? Graphs. Okay, all right. Number 3. So, I want you to, all right, use the x-intercept method when you're graphing. Okay, now I have up here both. I even put the answer up here for you. I don't know why, but I did. All right, which is okay, because I want you to show that the graph looks like that. So graph it on your calculator. Do an x-intercept method, which means we're going to put everything on the same side. So x to the 4th minus x cubed minus 12x squared minus 4x minus 10 is greater than 0. All right.
My dad and my mom's always like, but you always want to play basketball. These kids fish me out.
Hold on, you do it that way. I'm doing it the other way. Yours is not going to look like mine. Okay, now, yours looks like this one here on the, does yours look like that?
No.
Yes. Yes.
If it doesn't look like that, you made a mistake. Okay, because it should look like this. What? You don't need to put anything in Y2. Okay? All right, so check it, make sure yours looks like that. All right. Now, here once again is the reason why x-intercepts are better than finding intersection points in this situation. Okay? Because, what? I don't even see the second one. All right? The other problem is here that, let me change my window so I can see it. Let's go to 50. I think that should be sufficient. Okay, so now I would need to find my intersection points, but what does it say? It says, when is the graph on the left side bigger than the one on the right, correct? Okay, so in my case, when is blue larger than red? Well, when is blue larger than red? Okay, when it's higher, right? Okay, so blue is bigger than red when from this point on, which direction then? Left or right? Okay, to the left, right? Because when I go to the right, blue is below red. Okay, so here it would be from this point to the left, and here it's from this point to the right. Okay, so in yours that you have, all right, let me, remember what I need to do here? Okay, y1 minus y2, right? So alpha trace y1 minus alpha trace y2. Okay, and so now I will have the same graph that you do. Okay, so this is basically what you see, right? All right, let me move my window, change my window a little bit here, and we'll go, oops, I'll do that. More than I need probably, but. All right, didn't quite get all of it, but I got enough. Because all I care about now is when it's greater than 0, so I just need to find these two zeros, and then it's everything to the outside. So I'm going away, so I'm going to end up using the word or in this case then. All right, so we need to find those two spots. Anybody find them yet? All right, Jordan, what'd you get?
X is greater than 4.21 and the left one negative 2.97.
All right, so this is 4.21, and this one is what? Negative 2.97. Okay, so x is less than negative 2.97, or because we're going opposite directions, x is greater than 4.21. So on a number line, we would have open dots, arrow to the left, open dot, arrow to the right. Okay, so.
Do we have to, do we have to make a number line for those ones, or do we just have to?
Yes, yep. Okay. Now, how would I write the compound inequality for this one? That's the harder part. Okay, so we need to verify that then, or not the compound inequality. This is the compound inequality here. We need to do interval notation. So we're going to have two separate parts separated with an or again for the interval notation. So we have the one on the left. What's the smallest value for the one on the left? Because it says x is less than negative 2.97. So what number over here is the smallest one less than negative 2.97? Negative infinity. So we're going to have negative infinity to negative 2.97. Parentheses for both parts. For the one on the right, what's the smallest number? 4.21, and the largest number is positive infinity, and we're using parentheses for both. All right. Super duper duper. All right, quadratics. Factor, complete the square, use a quadratic formula to solve as if it was an equal sign, okay? Graph the approximate solution on a number line. Number 3, check 0 or another point to see if it's a solution. If it's true, then that section of the number line is the portion of the solution. So those are 3 steps that we're going to talk about as we do this problem. Okay? 3 steps to determining it. So first of all, my example is not the easiest one. Can you factor that? No. Woohoo! Yay! All right? Because we want to see something that's a little bit more difficult, right? So, since I can't factor it, what am I going to do? All right, complete the square. Great, I was hoping you'd say that. All right. So we are going to pretend, all right, not pretend, but we are going to do everything as if that's an equal sign until we get to checking to see where the answer is. Okay. So let's see, I need x squared plus 3x equals 2. X plus 3 over 2 squared, and then add 9/4 to both sides.
Yeah, I did that in just one step.
Did I write it too fast, Molly, or you want the steps? Okay. All right, okay. Hey, you're welcome to do the quadratic formula. All right, so I took the square root of both sides and subtracted 3/2. These last two steps, soon you should just be able to visualize them and go there. All right. All right, so we found the solutions. All right, we're going to graph them on the number line. Okay, these are my two zeros, right? So we're going to graph them on the number line. Right? So I need a couple of approximate values. Right? I don't need exact values. I need approximate. So we're going to use our brain. Okay. All right. Your brain ready? Okay. This is -3 plus the square root of 17 and -3 minus the square root of 17, right? Divided by 2. All right. Square root of 17, what is that? 4 point something, right? It's like 4.1, whatever. I really don't care. Okay? All I know is it's a little bit bigger than 4. So if I take -3 and I subtract a little bit bigger than 4, I get -7, right? Approximately. And when I divide by 2, I get, okay, so I get basically -3/2. So this left end point here is going to be between -4 and -3. Right? And that's going to be, this number is going to be -3 minus the square root of 17 all over 2. All right, we're okay with that. All right, okay. The other end, -3 plus a number a little bit bigger than 4 is a little bit more than 1. Okay? And 1 divided by 2 is 1/2. So we need to be between 0 and 1. Okay? So -3, -2, -1, 0, 1. All right? So I've got a 0 here and a 0 over here for them. Okay? And this is 0 and 1. And -3 plus the square root of 17 over 2. All right. Now, where do I shade on the line, right? That's the big question. I've done these problems a couple different ways over the forever of my doing this, okay? And the best method I found is, now it says check 0 or another point to see if it's a solution, right? So the reason I say 0 is because what's the easiest number to put into an original equation to see if it works? 0, because if whenever I put 0 in for x, I get 0, okay? So if I'm going to check to see if 0 works, and this is how this game is played. If 0 works, then the area between those 2 points is the answer. If 0 doesn't work, then it's the outside of them. Okay? Now, there's the easier way. Right? I can tell you right now that it's going to be between them, because what does this symbol say? It says less than. Okay? Less than. All right? A-N-D. And. The other symbol would be great or, and it would be outside. Okay? Less than, great or. Okay? Absolute value and quadratics work just like that. So when I put 0 in, we get 0 plus 0 minus 2 is less than or equal to 0. Is that a true statement? Yes. So my answer is this area between them. It works with quadratics and with absolute value. All right. Now, there is exceptions to them, of course. All right. What do you think might cause an exception? Okay. Nope. The exception would be if the coefficient of x squared is negative, then things reverse. Okay? Because instead of the graph opening up, because here's the thing. Here's what this graph looks like. This graph looks like this. Alright? Where is it less than 0? Between them. Okay? If the graph was a negative, that means it would frown, right? All right, and the greater part then would be between instead of on the outside. Okay? Right. So, but all you gotta do is check a point and you're golden. It works really well. Okay? All right.
We're gonna those ones in Wall Street.
No, I don't care. Okay? All right. You could, right?
Yeah.
Okay. Because all you gotta do is say is x is greater than or equal to this endpoint, less than or equal to that endpoint, and put bracket, number, comma, all right? Okay, last one. And this one is easier. This is easy. I hope it's the last one. It is, whether it is or not. All right, okay. All right, now, piece of cake here. Graph the zeros on a number line. See, we've got -6, -1, and 3, right? I don't care. I don't care that it's to the 4th power. It doesn't have any bearing on your answer. Oops, I need one more here. Oops. Back one. Has no bearing whatsoever on the answer. Okay. Now, I have 3 zeros, correct? All that matters. So I have a 0 since we have less than or equal to. I have a 0 at -6, 0 at -1, 0 at 3. So I put dots on those 3 zeros. Now, I'm going to check numbers between them and see if they work. All right, what's my favorite number? 0. All right, so we're going to try 0 first of all. And here's the thing, you don't have to do calculations. All right, and I'll show you why. 0 minus 3, 0 plus 6, 0 plus 1, is that less than or equal to 0? So, is this positive or negative? Is this positive or negative? Is this positive or negative? So I have negative, positive, positive. When I multiply them, I get a negative number, which is less than 0. So it works. So 0 works. That's a good point. So I know this area is good. So now I need to pick a number over here. All right? So what's a nice number between -1 and -6? I don't care. Okay? All right? Whatever you like, because all I care about is negatives and positives when I simplify. All right? Chris said -5, so I'm going to go -5. All right? So -5 minus 3, -5 plus 6, -5 plus 1. isn't less than or equal to 0. So I've got negative, positive, negative. So two negatives make a, so is that less than 0?
No.
No, so that part doesn't work. Guess what part's going to work then? This one here. Right. Most of the time, right, it'll be like this. Okay? All right. So your number line is good here. You could write a compound inequality. You would have to have the word or here to do that. Okay? Excellent. You guys are so smart today.